Hello and welcome. In this video, we are going to take our first look at Matlab while loops. This video is part of a larger series of videos that focuses on the fundamentals of the Matlab programming language. And specifically, we are going to take a look at how to construct and drive a while loop using scalar values. Now, I've provided you with the documentation for the while loop as well as the basic syntax. And so let's take a second to talk about why you would use a while loop. Well, the idea is with any loop that you want to reproduce or repeat an operation or a set of statements one or more times. In some cases, you'll actually discover that you can accidentally do it 0 times, but we'll save that for a later video. And the idea is that you want to continue an operation while an expression or while a condition is true. And so you can see here from the basic syntax that basically while this expression or while an expression is true, you want to execute a statement or series of statements. And so for a silly little example, we want to think of eating a bowl of breakfast cereal or perhaps a plate of noodles. And the idea is that you have no idea how many spoonfuls or forkfuls it will take to empty the bowl or plate. The general idea here is that with a while loop, you don't necessarily know up front how many times you wish to do the operation, in this case, basically using a spoon to spoon up your cereal or a fork to pick up your noodles, but rather that you want to continue the process until you are done. And in the previous example, then it is basically when the bowl or plate is empty. And the idea is that you won't necessarily know upfront how many times to do the statements, but you want to continue to repeat the statements until you have met some sort of condition. Now, we're going to go ahead and get started with some simple examples. In particular, we are going to focus on scalar values. This video does not assume that you have worked yet with for loops. You have, then perhaps you have a little bit of an advantage here. And so if anything, these examples are going to be pretty straightforward or pretty simple. To begin with, what we'd like to do is we'd like to use the example of calculating the area associated with a sequence of circles, that sequence being driven by a sequence of radii. In other words, basically, I want to calculate from a radii equal to 1 up to a value of 10, and basically calculate the area for each of the radii given. Now, to start off with, what we want to do is we'll make a couple of notes here. We're going to have our radius, and we're essentially going to start off value of 1, incrementing by 1 up to 10, and we're again going to generate the area or calculate the area for each of these. Now, I've written this in the vector notation just to help us with the documentation and explanation. However, we are not going to use a vector in this particular example. Instead, what we're going to do is we are going to start off with an initial value of radius equal to 1. And we're going to set up a while loop using this pattern of the expression. And in this case, what we're going to do is we're going to continue while the radius is less than or equal to 10. And then simply follow that while up with an end. Again, that's a similar pattern for most of the constructs in Matlab. Now what we want to do is simply calculate the area associated with each of the radius or radii. And to do that, we simply leverage then our pi times our radius squared. And there's a couple of different ways that we can go about doing this. Keep in mind, though, since this is a singular value, that you do not have to worry about using the dot caret notation. If anything, what I would encourage you to do, just for readability's sake, if nothing else, is to go ahead and use parentheses around this term. Now, at this point, then we've started with our while loop. We have a single statement. In this case, we want to calculate the areas. I'd like to keep this as a singular variable, though, pardon the typo. And then what we want to do is we simply want to display then the results. And again, we're going to use a combination of a display with an sprintf. You can simply ignore the warning here. And what we'll do is we'll first present to the user the radius. And in this particular case, since I am using integer values, I could technically use a %d, but however, I'd like to embrace the fact that these are in fact doubles. And what we'll do here is we'll use a similar pattern that we've used in earlier videos, and that is the %.4f. If you have not yet familiarized yourself with the sprint format spec, I highly encourage you to go ahead and do so. And then we'll follow this up then with the area. And again, we're going to use that same %.4f. And then we simply have two placeholders here that we need to populate. The first one, of course, being populated with the radius variable, and that second one being populated then with the area variable. Now, normally at this point in the video, I'd simply just go ahead and highlight and run this. But if you've been following along a little bit, you can probably guess that there is a problem. Now, I am going to go ahead and run this in just a second, but I want to tell you about what's going to happen before it happens. You'll note that basically the radius itself is not changing. So what we've done here is we've effectively created an infinite loop. In other words, there is nothing happening to update the expression or the condition that is being checked in the while loop. And this is probably going to be your number one mistake when you're starting off working with while loops. Now, let's go ahead and do this. We'll go ahead and run it, and you'll see that basically what it's doing, it's running. You may or may not be able to tell very well in the video, but at this point, basically, it's just running unbridled or uncontrolled. And again, since you're going to probably do this at some point, you just simply click down here in the command window and hit Control-C, and then MATLAB will stop or terminate the script. Now, how do we fix this? Well, it's pretty straightforward in that we simply need to change the condition. And in this case, we simply specify that we are going to add to the radius value. In this case, I'm going to add the value of 1 to increment it. And technically speaking, since this is an operation with doubles, I don't have to worry about the 0.0. Let's leave it like this, again, for clarification's sake on this particular example. Now, if we highlight this again, and evaluate the expression, you'll see that this time the loop runs correctly. And in other words, it doesn't run infinitely. And you can see that I'm calculating the area associated with each of the radius from 1 up to 10. Now, we are not, in fact, limited to simply incrementing in a positive direction, much like what you'll see when you're working with for loops. We can also do the same operation to essentially count down. And so let's repeat this real quick. We can borrow some of the code here, but I'm going to start off now with a radius equal to 10. I'm going to set up again my while loop here. And in this case, what I'm going to do is I'm going to very carefully write the condition such that while the radius is greater than 0, and I'm doing this very specifically, and you'll see why in just a second. In the earlier loop, you'll notice that I used a less than or equal to 10. In this case, I'm going to use a greater than 0, and the idea is that I want it to stop essentially at that last value of 1. And again, we'll follow this up with an end. I'm going to do the same calculation here. Area is going to be equal to pi times my radius squared. And at this point, you could probably see that we're going to be borrowing a lot of the same code. So if anything, what we'd like to do is to simply copy and paste our nice little display and print F. It appears as if my clipboard has failed me. So I'm just going to go ahead and retype this here. And so we again have our %.4f, area equal to %.4f, and then as the two placeholders again, our radius and our area. Now this time around, since we're trying to count down, we simply modify our little incrementer and we turn it into a decrementer, if you would. In other words, we're going to subtract 1 from it. And you'll notice that in this case, I will start off at 10 and I'll simply count down to 1. And you'll notice the way that I've crafted the expression for the condition, in other words, the radius greater than 0, I do in fact not include 0. Now let's just temporarily go ahead and change this to a greater than or equals, just so you can see what the behavior would be. You can see there that basically I include that last value that I may or may not want to include. Now, optionally, what you could do is you could, of course, just simply change the end condition, but I'm going to leave this one alone for the purposes of demonstrating one more example. And that will be to leverage our values of theta from 0 to 2 pi. Now, why am I doing this? Well, I want to emphasize the fact that these do not need to be integer values. And so what we want to do for this third example is we want to simply calculate the values for sine and cosine using a theta that goes from 0 increments in pi over 4 or some other relevant increment up to 2 pi. And again, I'm using the vector notation here, which we will not necessarily use or not have to use in this particular example, but I'm going to calculate then the sine and cosine. And again, I want to simply display them to the console. And so to begin with, what we're going to do is we're going to initialize the value of theta equal to 0. And I'm going to set up my while loop in such a way that while theta is less than or equal to 2 times pi, we simply want to calculate and then print out the values for sine and or cosine. And again, what that means is we're simply going to be using a display combined with an sprintf. Alternatively, you can, of course, use fprintf. However, I talk about why I discourage that in another video. And then what we want to do is have our string here, or rather our character vector that is our template. We'll start off with our theta equal to, again, %.4f. Seems like a reasonable pattern. We'll go ahead and do our sine here. Again, I'm going to go ahead and put a little bit of a fancier placeholder here. I'm going to say sine of %.4f is going to be equal to %.4f. And if you're interested, you can always continue this on with the cosine. But since I've got 3 placeholders, that's probably enough. We're going to replace the first placeholder with theta, the second one with theta, and then the third one will simply be the sine of theta. Now, at this point, then you'll notice that we again have the same problem that we had in our earlier example, and that is that we are not changing the value of theta. Now, if we were to run this right now, it'd simply have an infinitely running loop that we would again have to hit Control-C to get out of. But we're hopefully learned something here, and the idea here is that we would then know that we have to change our condition. And in this case, to follow the example with the vector that I have listed on line 29, I would simply say theta is equal to theta plus our pi, in this case, over 4. Now, I'm going to go ahead and highlight and run this particular example. And if we don't have any typos, you should see a nice little table there of theta. And then the sine of theta, you'll notice how that second placeholder is being used, again, just to make a nice looking table. Now, you'll notice that I do, in fact, stop at 2 pi. And the reason I wanted to point this particular example out is that in cases where you are using a function, or in this case, pi, or have some sort of irrational number that you are leveraging in your while loop to drive the while loop, you need to be really careful about that ending condition. In other words, if you have round off error that is continually over the actual value, then you could end up having a cumulative round off error where that last value does in fact not get calculated. Now, in this particular case, Matlab avoids this issue, so we don't have to worry about it. However, be careful again when you are using doubles in the context of a while loop condition, in that your last or final condition of 2 pi may or may not run. So hopefully you found this video useful. We'll be following up with other videos on while loops and focus on different ways of driving them, particularly with vectors of different data types. But as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.